Welcome to qnawire.
Derivatives and second derivatives are very powerful. They ultimately allow us to determine the shapes of graphs. That's one really special use of them. And that's what we're going to see in this problem. The fact that we can take derivative, we can take the second derivative, and we are able to see minimums and maximums, concavity, and a lot of other really important details within graphs. So this is the graph that we are dealing with for this problem in particular. And we first want to determine intervals of increase and decrease. So we see the graph is decreasing from negative infinity to 0. It increases from 0 to 1, and then decreases from 1 to infinity. Then we want to determine local minimums and maximums. We see that there's a local minimum right here at 0, 0. Interestingly, if we look at the derivative graph, we see that it's undefined at this point 0, which also indicates that it's a critical point and a local minimum. And then we see there's a local maximum at 1, and it's this value here, 1, 3. With that, we now want to move on to concavity. We see that the graph is concave up until negative 1/2, and then it becomes concave down, and it's undefined at 0. Then it goes concave down, and it remains concave down for the rest of the graph. And when we have these sharp turns, it makes things really interesting because the graph is not actually differentiable at that point. Then we have, now since we've determined concavity, we can also determine inflection points. We see that this is where the second derivative graph equals 0, so that tells us that negative 0.5 is an inflection point of this graph.